Do you remember the early 2000s? A simpler time where you could download Linkin Park num.mp3.exe from LimeWire and give your family computer a disease that I will not name here on YouTube. Computers have come a long way since then, and it used to be back in the day that you could click on a link or open a website, and that in itself would own your computer. Now, it has not been that way for a long time, but the vulnerability today is kind of reminiscent of a simpler time back when computers could be owned by going to a bad website or opening a bad file. Hackers exploiting Acrobat Reader 0-day flaw. Since September, an article about a vulnerability that has been seen in the wild in the way that Adobe Reader parses PDFs, and in particular, the JavaScript engine in Adobe PDFs. I'm gonna be completely honest, I didn't even know that you could run JavaScript in a PDF. I think that's a feature that no one really wants, that no one asked for. It's kind of like how if you go to Notepad right now and you open it, you'll notice you have Copilot here at the right. Again, a feature that no one wanted or asked for, and I think just adds an unnecessary attack surface to a piece of software. Now, that being said, Adobe PDFs are meant to be a little more pretty. You gotta have some animations in there maybe, so maybe JavaScript is necessary. But as a shock to nobody, the ability to run JavaScript in a PDF is what caused the bug today. The research I'm going over today, by the way, is by this guy, Haifei Li. I'm sorry if I mispronounced your name, man, but go check their work out. Obviously, I'll link their blog in the description below. But he runs an entire platform for literally just detecting malware that is doing a sandbox escape. So if you're not aware, Adobe Acrobat is a software that obviously has a variety of issues. One of the good things that it does is the internal JavaScript runs in a sandbox. A sandbox is literally just a software way to prevent code from doing certain things. You don't have access to all the APIs, all the files. You can only do a restricted set of things. Now, attackers, obviously, when they're given a sandboxed environment, are looking for ways to escape out of the sandbox. They're called sandbox escape exploits. Now, his system, XPmon, that monitors, I guess, software that is trying to do sandbox escapes, or software that can have sandbox escapes, like Adobe, for example, detected this one sample that uses a very, very novel fingerprinting technique to eventually pull down the exploit that pops Adobe. So you'll notice here that if you're not really aware of how PDFs work, PDFs are just a series of text objects that are concatenated together. Some of them are compressed by gzip and some are just in plain text. And so here you'll see one of the streams that is just a bunch of obfuscated JavaScript that if you de-obfuscate it, turns into this little tidbit here. app.t equals blah, 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 effectively d base 64 encode the value in a button, the button being the field button 1. Okay, so you can see here, this is the base 64 data that was seen on that button. If you then look at that base 64 decoded, you get to very quickly see this is a bit of obfuscated JavaScript. This is JavaScript that was obfuscated in a way so that you, the reader, can't initially see what's going on here. This is a very common way that threat actors hide the functionality of malicious JavaScript. They put it through some kind of obfuscation run that has a bunch of different misdirection and bad variable names that it's basically impossible to read in its current form. Now, just like any code that runs locally, right, even though it is obfuscated, at the end of the day, it does have some underlying functionality, which you can use to reverse engineer the intent and use that to give more meaning to the code, to replace these labels, these bad variable names, and make it make sense. So Haifei used AI here a little bit, which again, I think is a good use of AI. If you have something local that you want to just kind of automate and quickly iterate on, AI is a great way to do that. And so they found that the malware is actually doing something really novel. So like any good sandbox, right, it does not make sense to give the contents of inside a sandbox access to the internet, right? It's the same reason why in the JavaScript environment in your browser, you can't do arbitrary socket data. You can't do arbitrary network requests, right? You can do like a fetch, you can do like an HTTP request, but you cannot do arbitrary execution of open UDP port 6969, right? Because that would give an attacker that runs bad code on your browser access to your network, which is not a good time. It's an intentional sandbox design. And similarly, for a long time, there were no real ways to run network code inside of the Adobe PDF sandbox until this was found. So apparently, and I didn't even realize that RSS was still even a thing, you can use the RSS engine in Adobe to arbitrarily run requests. So you can use the RSS feed functionality to call out to some other server where apparently this threat actor had more code waiting. And so inside the actual code that does the call out, you can see it does a bunch of really interesting stuff. It's collecting the language of the PDF reader, the viewer type, the viewer version, the platform that they're on, the amount of active documents open, and also this one little function called to get prod version string, which does a very unique way of actually fingerprinting the exact version of Windows. So you look at this piece of code here, the get product version string function, literally, all it's doing is it's using a privileged sandbox function, which again, I'm not sure why this function exists, util read file into stream. It's able to arbitrarily read ntdll.dll, which is a core DLL that like all programs use on Windows. And what it does is it searches for this exact string of hex inside that DLL, which precedes the version of ntdll, which is a direct indicator of what version of Windows you're on. So it looks for this string and says, okay, right next to it, it's going to be our version of Windows. And it takes that offset, takes it, converts it to a proper integer. So we go from a string to an int, and then it sends that off to the server. All of that data is used to return an AES encrypted blob, and that blob is additional JavaScript that gets run by the reader. One thing that really scares me about the world of AI is not what the AI tells you, but what people are telling the AI. And that's why today's video is sponsored by Island. Island puts control of AI in your enterprise directly into your hands. Island's enterprise browser gives you visibility into not only what AIs are being used, but what data is going into those AIs. Island's enterprise browser uses a data tainting strategy, which means based on the source or the contents of that data if it's sensitive or not. And then Island's browser will stop you from pasting that data into a site like ChatGPT or Claude. And so because of this, certain types of data like usernames or credit card numbers from your customers can't be put into certain sites. So when an engineer tries to format a CSV file to a JSON that has a ton of sensitive customer data, Island's enterprise browser will stop it. And the patterns aren't one size fits all. You get to tailor your data policy to your organization's needs. Guys, you know the rule. The best way to help the channel out is to go check out the sponsor, go check out Island, go see if Island's enterprise browser is the right solution for your organization's AI security needs. So if you want to stop those AI leaks today, your company, go check out Island's browser. Island, thank you for sponsoring the video. Back to the video. Now, this is the inherent problem when you're doing research on like exploit servers, right? So what's happening here is that this is literally just being used as a loader to shoot off to a server and tell us, hey, can you deliver the payload that exploits this version of the thing? This is a very common threat actor tactic, right? And so the problem is when you get a sample like this, it's very hard to reproduce a functionality that will get the actor to give you the payload, right? The reason why they do this entire system is so that if there's some really weird exploit that gives you either RCE or complete escape out of a sandbox, they don't want you, the person potentially looking at the malware, to have it, right? All they want is to fingerprint you and then send you down the version if they think that you're not watching. And so the researcher, they tried to reproduce this and they couldn't get the server to send the exploit back. Obviously, it's a very common tactic, but using their own kind of mock-up network of this system, they were able to use their own server to send back JavaScript that gets run inside of Adobe Reader. So they were able to prove, okay, if I were this attacker, I could send back down another blob of JavaScript and run it. Now, here's the problem. There is an active RCE or sandbox escape vulnerability that is in the wild being exploited. We know this because on April 12th, Adobe themselves published a security bulletin that said, hey guys, there is an active critical vulnerability that leads to arbitrary code execution. We can't tell you what it is. You probably could go patch diff and figure out what the two changes are, but I'm not trying to do a patch diff on the entirety of Adobe Reader. But basically, you know, just like any file format, right guys, PDFs are just a text-based file format that somewhere in the code is getting parsed, and just like anything, a parser can get it wrong. And in particular, we are using a parser that is parsing and executing JavaScript code, which is a very common attack surface in browsers. So similarly, it's an attack surface that can be exploited inside of Adobe Reader. Now, obviously, the nature of finding and exploiting a vulnerability in an environment like the Sandbox environment or like the JavaScript Sandbox environment is very complicated. And so those are very closely protected, right? The actor is not going to just shoot this out at everybody. They're going to make sure that you're not watching, that you are the right fingerprint for them, and that they don't just send it to you willy-nilly. Flashback to the early 2000s, we're kind of there again, right? So as usual, right guys, don't be just randomly opening files people send you. This applies to Word documents that can have evil VBS macros and also PDFs, right? We are still in a world where PDFs can have malicious data that can reach out to and pull down information and then eventually exploit your browser. We don't know the exact details of this RCE, but we have confirmed from Adobe that it exists. So it's very careful to look out for this. In this particular sample, there is this IP address here. So if you're in like a knock sock environment, please go and like set up indicators for these. And obviously guys, there's a world where like there are multiple IP addresses being used for this. So make sure you're kind of looking out for maybe these patterns, right? Language, platform, active docs, viewer version, etc., all in the request. request. And the question on everyone's mind, would Rust have fixed this? Not really. This is more of like an implementation issue, right? Where like there are certain functions that I guess Adobe was not aware the JavaScript Sandbox had access to. So the ability to not only read files into a stream, but then also use the RSS functionality to make callouts is kind of an interesting problem, and not one that you would actively think about, because RSS, at least, like I thought RSS was dead. I forgot about it. Anyway, guys, that's it for now. Thanks for watching. I appreciate it. If you like these videos, hit that sub button, hit like, and then let me know what else you want to see in the comments. Let me know what other kinds of videos you want to do, and then go check out this other video that's about a hack that's just as cool as this one. We'll see you over there. Take care. Goodbye.